Hello and welcome to Pharma-info with Shivashish. Now today the topic is another synthesis, that is synthesis of phenytoin, right? Now, so phenytoin is a well-known drug, right? It's a well-known drug, and this is basically ever since it came into the market, and still it is raining like anything, right? And phenytoin is given to the patient who is suffering from what? Convulsive disorder, that is epilepsy, right? Or seizure disorder. There are different verbatims which are quite often been used, like seizure disorder, convulsive disorder, epilepsy, right? So it's an anti-epileptic drug, it's a primary choice, right? Let me tell you, it's the primary choice, and nowadays they are just derivatized phenytoin into phosphenytoin, right? Phosphenytoin, right? There's another drug obtained from phenytoin, right? Obtained from phenytoin, right? So that is all about your the clinical indication in which phenytoin can be given, right? Now coming to this, the structure of phenytoin. So the structure of phenytoin, what can be extracted from the name, right? Toin for hydantoin, toin for hydantoin, and phenyl for phenyl, right? So that means hydantoin with phenyl. Now what is hydantoin? So what is hydantoin? Hydantoin is nothing but, it is something like this. This is your hydantoin, right? This is your hydantoin. Now where to place the phenyl? So here the extra thing that you need to remember is phenytoin possesses multiple phenyl placed at position 5. So here we have to put 1,6,H5, here we have to put 1,6,H5. Now this has become what? Phenytoin, right? So this is hydantoin. Hydantoin is basically imidazolidine 2,4-dione. So this is your hydantoin. Hydantoin is a 5-membered ring system, containing 2 nitrogens placed at position 1 and 3. 1 and 3. And if so, 1,3 nitrogen, and that to a 5-membered ring system is called as imidazole. But let me tell you one thing: as there is no pi bonds that is placed inside the ring, and that is why no longer we can call it as imidazole. Instead, we should call it as imidazolidine, right? Imidazolidine, devoid of both the pi bonds, not both the pi electrons, right? Because we have 4 pi electrons and 2 pi bonds, right? Make sure. Now the thing is that, so this is basically imidazolidine. So 1,3 imidazolidine 2,4, because this is 1. If we start numbering from here, 1, 2, 3, 4 and 5, right? So this is basically imidazolidine. If I just say what is hydantoin? Hydantoin is found to be, there is no phenyl as such in hydantoin, right? In hydantoin is basically imidazolidine, 1,3 imidazolidine, okay? 1,3, you see, when you are calling it as imidazole, no, there is no point in just mentioning the number, right? The number, right? So we are not supposed to mention the number, rather simply it's imidazolidine 2,4-dione. Now, if we just move on to phenytoin is having the extra things, that is phenyl. 2 phenyls, that means diphenyl. Where it is placed? Position 5. So likewise, how the IUPAC name goes? 5,5-diphenyl. So 5,5-diphenyl. Then straightway you can write hydantoin, no problem at all. But as you know the factor file that is there in this particular structure, so that is why 5,5-diphenyl imidazolidine, then 2,4-dione. That's all, right? So we are done with the IUPAC name of what? IUPAC name of phenytoin. Now the next thing is how this can be synthesized, right? How the structure of phenytoin can be synthesized. It's a one-step reaction, right? It's a very simple, and basically PCI, they have framed, Pharmacy Council of India, they have given, they are asking us to synthesize this particular thing in our lab as well. But during this COVID pandemic, it's really impossible to make it in dry lab. So let us just satisfy with this wet lab making and all, right? Sorry, dry lab making and all, right? Because they are asking us to make it in wet lab, right? But unfortunately we cannot go into the lab. That is why we'll just make it dry, right? Chalo. So now how this can be made? First and foremost, the structure, that is, as usual, the usual strategy, okay? Because opting this particular strategy, I think that we have got so many things, right? So this is your phenytoin, right? Okay. Now, from where this can be broken? Because this can be broken, as I said, this is found to be a single step reaction, right? Okay. Now, this can be broken down into two different parts. What are those? This is the area from where we can separate both the fragments, right? Okay. Now we have got two fragments. So one is found to be NH, C double bond O, NH, right? The usual sense says that if we just make it NH2, it will become what? Urea. Urea. What about this? What about this, right? Okay. For that you might have heard about benzylic acid rearrangement, right? Benzylic acid rearrangement as well as benzyl, right? Okay, benzylic acid, how it looks actually? Benzylic acid is found to be something like this: H5C6 C C6 H5 OH COOH. And let me tell you, this particular acid is obtained from benzyl. How benzyl looks? How it looks? Benzyl is found to be H5C6 C double bond O C double bond O C6H5. Right? Now, why I am writing these two acids and all? One acid, the other one is diketo compound, right? Okay, as we can get this kind of acid from this particular thing where two carbons are holding two phenyl, right? Okay, that means it is the two carbonyl carbon that is flanked with two phenyl, right? But here, when transformation will take place, that time in this particular acid you won't find that both the phenyl rings are found to be evenly distributed with both the carbons, right? Rather, a rearrangement took place, and it is the rearrangement that eventually leads to the production eventually leads to the formation of this kind of compound in which a single carbon is holding what? Both the phenyls, right? Okay, so that means if we can incorporate this kind of reagent into this system, you may land up to this kind of arrangement. Because if we start up the process with benzyl, irrespective of despite of knowing that benzyl itself cannot provide us a feature in which carbon is holding two phenyls, right? But still we know the fact that it is the benzyl that is utilized in making benzylic acid, in which both the phenyl is being held by are being held by a single carbon, right? So that means this is found to be the another choice, right? This is found to be the another choice, right? Okay, chalo. So with that we have got what? With that we have got both the starting materials, right? Both the starting materials which are involved, or both the essential materials of the reagents which are involved in making phenytoin, right? Okay. So how it goes? So first one is your urea, like this, H2N, C double bond O, then NH2. I'll just write it in this way, right? In this way. And the other thing is nothing but benzyl, in which C6H5, then C double bond O, then C double bond O, then C6H5. And let me tell you, as we are thinking that a shifting has to be taken place, right? And the shifting has to be taken place in presence of a base. You can go after taking sodium hydroxide, no problem at all, right? Sodium hydroxide, because it is the base that will provide the nucleophile for the reaction to occur, right? Until and unless this electron deficient center, carbonyl carbon, they are not being attacked by some other nucleophile, the rearrangement will not take place. And if there is no rearrangement, forget about the final formation of what? Phenytoin, in which both the phenyl should be placed in a single carbon. That means a single carbon should hold what? Both the phenyl, right? So if we just merge what? Urea with benzyl, what will we get? What we should get at the end of the show? You should get what? Phenytoin. And during the process a rearrangement will take place, and that too in presence of a base, right? Okay, chalo. And finally we have got what? We have got 5,5-diphenyl imidazolidine. As I said, no need to mention the position of two nitrogens. Why? Because imidazole itself, self-explanatory. Imidazole itself suggests that I am holding two nitrogen which are placed at position 1 and 3, right? So that is why imidazolidine 2,4-dione. That's all. Hope you have enjoyed this particular session and all. Please do subscribe my channel and put your valuable comments. If you like my video, then don't forget to press the like button, okay? And so thank you very much. Now stay tuned and wait for the next video to come. And in my next video, definitely I'll come with another synthesis, right? Thank you for your patience. Thank you.